So 6.4 is about a thing called complex rational expressions. So for most people, it's probably not the thrill of your life that the lesson title has the word complex in it. Okay? I will tell you, I don't think this is really that complex. If I had to pick between what homework I think is harder, yesterday's or today's, I pick yesterday. I think this homework will be easier than yesterday. So the title of being complex, I don't think that's fair to the process. But it looks sort of complicated. Okay, so what complex rational expressions are, it's anytime you have fractions that have other fractions inside of them. So I think the appearance of these is complex. You look at this and you're like, this looks bad. I agree with you, but this won't be bad. But it does, it looks bad. The look earned the title, not the difficulty of what the homework's asking you to do. So here's our process. What we're going to do is we're going to find the LCM by looking at all of the bottoms, which might involve you factoring. When we get farther down the board, people that can see the whole room right now, not the camera people, but other people, there's some factoring down the line, okay, looking at the bottoms. But we're going to find the LCM of all the bottoms, maybe by having to factor. So let's look at this one. Just look at the bottoms only. What would be the LCM of all the stuff that's on bottoms? 14. There's a 2 on the bottom, there's a 7 on the bottom. LCM is something that those both go into, so 14 is the LCM. So that's our first move, question about picking LCMs. We've done that for a couple days now. Okay. What we're going to do with that LCM is we're going to multiply every term on their tops, or if they're whole numbers as well, because whole numbers are on top of invisible, any whole numbers on top of an invisible one. So we're going to multiply tops, we're going to multiply any whole numbers we find by using that LCM that I just circled. Goal being, we're going to cancel all the bottoms when we do that. That's why we picked the LCM. This is kind of like an advanced version of what the 7th grade book called the name changer machine. You're allowed to multiply the top as long as you also multiply the bottom. So if we go through and we multiply both of these things on top, and we also multiply both of these things on the bottom, what we've done is legal. We've changed both top and bottom in the same way. So let me do the fractions first, because that's the most important thing. But we're going to end up with this plus that on the top. We're going to end up with this minus that on the bottom kind of stuff. Okay, but why we chose 14 is because 14 is a 2 canceler. When 14 cancels 2, it leaves us 7. Multiply the top, we got a 7. 14 has nothing to cancel here, so it's just multiplication. Okay, what we're doing here is multiplication. So 14 multiplies that, 14y. We also chose 14 because it's a 7 canceler. When 14 cancels 7, it leaves us 2. Multiply the top, 6. 14 also has to multiply that. And then maybe we're done. Maybe we simplify. Okay, so I say simplify question mark. Can we right now cancel those?
No.
No. We've talked about that for a few days. You can't cancel things when they're wrapped up in can't if they're in adding or subtracting. We can cancel if they're multiplying. This invisibly has parentheses. If you wanted to, you could factor out a 7. This is in parentheses invisibly. You could factor out a 2. But can a 7 cancel a 2?
No.
No. Would what we have left be a match if we did that factoring? No. So do it or don't do it. No one cares. This is acceptable as an answer because factoring can't lead you to a cancel. But if we want to cancel, you're probably going to have to factor to lead you to that cancel. Question about the general scheme? Okay, so let's do it again. What part of the problem are we looking at first? All the bottoms. We look at all the bottoms and we're trying to pick the LCM. What are we going to pick for an LCM? X squared. Because the word of the day for LCM was we picked everything the most we ever saw in one place at one time. So this has an X. This has an X squared. We're only looking at the bottom. The most we ever saw in one look was the X squared. Question about picking LCMs. So now we start multiplying. Okay, the purpose of multiplying, the main purpose of multiplying is to cancel all the bottoms. The top is still going to add, the bottom is still going to subtract, but we're going to get some cancels going on. So let me do this one first. When x squared cancels x squared, it's a perfect cancel. The only thing left is 1. When x squared perfectly cancels x squared, only thing left standing is 1. When x squared cancels x, it's an imperfect cancel. Who's left? X. Multiply that top.
X.
That's an x. What does the x squared have to do to the 1s? We're multiplying. So this becomes x squared, x squared. And then maybe we're done, maybe we aren't. Question about that. We can't cancel right now because this is all adding and subtracting. That's not legal. But if we can factor, maybe we can cancel. Does the top factor it?
Yeah.
Yeah, what can you do?
Take on an X.
Take out an x. Leaves you
X plus 1.
x plus 1. So that's out. New thing is in. And the bottom factor.
X plus 1, X minus
X plus 1, x minus 1. Does that help us in any way to cancel?
Yes.
Yes, that's why I wrote it down, because I saw that coming. So I can cancel
X plus 1.
x plus 1. So final answer, best answer,
X minus 1. X.
top has
X.
x, bottom
Minus 1.
x minus 1. 2 down, 3 to go. Question about that pair. Okay, so questions while we were moving along the line is, have we done this before? The answer is yes, you did this in Algebra 1. So if this seems vaguely familiar, it's because it was. And then we had people commenting that this one looked awful, but I'm saying this will be probably the one you'll like the best, actually, in the long run. If we go to this one, again, where are we looking first? All the bottoms. And picking the LCM. So what do you see? XY. I see a few x's, but never more than one. I see a few y's, never more than one at a time. So xy is the LCM. What's the LCM's job? What are we picking it? What's it trying to do? It's going to multiply the tops, but the more important goal is it's going to cancel all the bottoms. We're trying to cancel all the bottoms. So the top is still going to have a plus. The bottom's going to have just like a single thing. So if I attack this piece, we get rid of the x's, left standing, y. If we attack this one, get rid of y's, left standing, x. When we attack this, we get rid of x and y, and we're left with x squared minus y squared. And in some problems at that point, you're done. In other problems, maybe we can get this to simplify. Question about getting there? Can we factor anything? That's what lets us cancel.
X plus X squared minus, you did X plus Y, X minus Y.
X plus y, x minus y from the bottom. So that's out, and friends are in. That's in parentheses, whether I write them or not. Does that get a cancel going?
Yeah.
Yes. Does it matter that these are backwards?
No.
No. Top, it just has a 1,
X minus 1.
x minus 1. If these were subtracting backward, that would matter. What would we have to do? We can still cancel them. If they were subtracting backward, how does that impact the answer? Throw a negative sign in the answer. It'd be a negative 1 instead. Something about that one. Okay. So same thing. Always start off, look at all the bottoms. What do you see?
XY.
XY. So we're going to have that XY attack, and what's it going to get rid of?
All of the bottoms.
All of the bottoms. So it's still going to be adding something, subtracting something, still the big fraction bar, still an add, still a subtract. It's just a question of who's going to be left standing. Let me go to the end, because this is the easiest mark.
8.
That's just an 8. We get a perfect cancel there. Just leaves an 8. How about this slot?
16.
16, because we get the same sort of a perfect cancel there. Anybody puzzled by that? So what's this going to be?
6X.
6x, because the y's are gone.
12X.
12x, because the y's are gone.
5Y.
5y, because the x's are gone.
10Y.
10y, because the x's are gone. Sometimes we're there and we're done. Sometimes it's going to go another little baby step. Question about how we got there. You can't cancel unless you can factor. Can anything factor?
You take 2 out.
Bottom can take out a 2. Gets you 1.
5 plus 6x minus 8.
Did that help us?
Yes.
Yes, because that top is a perfect match. So factoring, that's out. Best final answer? Half. So we started with this incredible monstrosity, which was complex looking, but we're getting a half. So again, I'll say, the appearance of the problem earned the title complex. I don't think this process is bad. I would much rather, if I'm you, do this homework than do the one that was from previous section. I think there's a lot less to it. Question there? This one I'm just going to title Factor Mania. Yeah, I'm not going to follow the same steps. I think just looking at this, you realize it just looked different. So I'm going to just say, let's go Factor Mania. So level 1, top level,
X plus 3, X plus 2.
x plus 3, x plus 2. Middle level,
X plus 4, X plus 6, X plus 2.
x plus 6, x plus 2. Third level,
X plus 3, X plus 1.
agreed. Bottom level,
X plus 8, X plus 1.
x plus 8, x plus 1.
Oh, these are about to get big.
No, it's going to get real small real fast. I'm going to stick the answer right there. I'm going to need that much more space.
Oh, and you're sure.
Question at all about how we factored? Okay, then let's have a flip a mental switch. What does this mean? This math symbol means divide. If you have a fraction and you divide another fraction, that means that you have to flip the second fraction. So this is a top that would stay a top. This is a bottom that would stay a bottom. This looks like it's a top, but really it's a bottom because we're going to flip, and that's going to be a top. If you follow the logic of that, great. If you don't, just on your paper when you do this the next time, write TBBT out of faith. It'll always go TBBT out of just experience. Any top can cancel any bottom. So anybody on a T level can cancel anybody on a B level. So where is there a T that can cancel a B?
X plus 2.
X plus 2 is a T, X plus 2 is a B, so bye-bye.
X plus 3.
X plus 3 is a top, X plus 3 is a bottom. Bye-bye.
X plus 1.
X plus 1 is a bottom, X plus 1 is a top. Bye-bye. And this is telling us to put the X plus 6 on a bottom and put the X plus 8,
On the top.
and then you take your bow. And that's probably the one people like the best, historically speaking. It's like, you can do Factor Mania for the most part, because that's what we've been doing for 2 months. So Factor Mania, a little TBBT, cancel like mad, let the stuff work out. Question at all about complex rational expressions? If it goes crazy snow tomorrow, then just like watch a 6.5 video that would need to be produced. I'll just wander down to school and I'll record 6.5 because we wasted enough days already this week. So if 6.4 tomorrow leads us to 6.5 and it snows, a 6.5 video will appear. Watch it sometime over the weekend and we'll hit that up. 6.5 is the last little bit of learning before we come to a review point. So in terms of our schedule, snow or no snow, tomorrow would be 6.5. Monday we'd go over homework from 6.5. Tuesday a sheet would be due. I'm going to give you the sheet now because most of you are here finally for the first time in a little while. So I'll give you a sheet that's due Tuesday that you could get started on whenever. You know how to do 80% of it. The only thing you don't know how to do is 6.5. And if you go to look at 6.5, 6.5 is another thing you've done before. So 6.5 is old news from Algebra 1 as well. We'd be looking to take a quiz next week, Wednesday. Wednesday is also the end of the grade period. We're ticking down. We're at a 4-day count right now, so any homework needs to come in by then. Question about any of that while we're still on the record zone? Here's one other bonus feature that I have to tell you, otherwise you're gonna be, some of you forget this. If they write on your homework and they do x to the negative 1, does anybody remember what that exchange is to be written? 1 over x. What if it's x to the negative 2?
1 over 2x.
1 over
X squared.
x squared.
3.
If we go x to the negative 3, that's
1 over x to the
1 over x to the third. I see some in the homework when I glanced at it, that they're written with these negative powers. When you copy the problem down to work on it, just exchange that for its fraction counterpart. But yeah, homework is 262, 1 to 22. Give it a try. The worst ones are going to be 17 and 18. 17 and 18 are going to be significantly harder than anybody else. So if you get to 17, 18, you're like, this seems harder. That's true. 17, 18 are the hardest two. It gets easier again on 19. 19, 20 are more like this one. 15, 16 is more like factor mania. But in the middle of those, 17, 18 I think are the hardest two. There's going to be some foiling going on because your LCM is going to have parentheses in it. And then the tops are having parentheses around them. When this multiplies that, you're going to have a little bit of foiling when you go to take on 17, 18.